Hello to all my junior naturalist friends. This is Ruth. I'm one of the naturalists at Beaver Creek Reserve, and today I want to do a science experiment with you. Science experiments are always really cool. But doubly cool about this one is that if it turns out, you're going to have a tasty treat at the end. You can decide if you're going to work the experiment with me, which means you're going to be hitting the pause button quite a bit. You'll watch a little bit of the video, pause, and then you can get your stuff, set it up however. You can watch the video all the way through, take some notes, and do the experiment on your own afterwards. It's all up to you. But since we're dealing with food, the very first thing I have to do before I start my experiment is I have to wash something. So give me a second, I'm going to go wash my hands. Alright, my hands are clean and I am ready to begin. Now, we're going to be following a recipe. And so when I'm in the kitchen or before I start cooking or anything like that, I kind of like to make sure I have everything I need before I start. Otherwise, it gets to be kind of a mess. I got my recipe from a place called Science Buddies. So our experiment today, we're going to make some ice cream and we're going to test and see if salt makes the ice cream form faster or slower. So my list told me that I needed measuring cups and measuring spoons, that I was going to need sugar, some vanilla extract. The recipe actually says half and half. This is a recipe you can substitute. Sometimes if you're following a recipe, you cannot substitute one thing for another. But in this case we can. Half and half is half cream, half milk. So what I bought was heavy whipping cream, and then I'm going to use reduced fat chocolate milk. So I wanted the fat content to come back up. You can use just regular milk. You can use just whipping cream. You can try different experiments, but for today's experiment, you want both sets to be equal. And I'm a chocolate person, so I'm going to experiment. I've never tried this with chocolate milk before. So I'm going to go ahead and try it with chocolate milk today. You're going to need two sandwich bags, the Ziploc kind, and you're going to need 2 gallon-size Ziploc bags. You're going to need some salt. Now this salt is not table salt. Table salt will work, it just doesn't work quite as well. If you can get a coarser salt, coarser means that the individual grains are bigger, the crystals are bigger, that's going to work better. So this salt, it's rock salt that gets used in a water softener. Now you want to be careful not to use ice melt. Ice melt is not salt, is poisonous, and won't work quite the same in this experiment. So you want salt, and ideally you'd like coarse rock salt. Alright, I'm going to pull you in a little bit closer so that you can watch as I mix the ingredients. Okay, so we checked. I have all the stuff I'm going to need for this experiment, for this ice cream experiment today. And I'm going to start with the 2 smaller bags. You want what goes into the 2 smaller bags to be exactly the same, because otherwise the experiment isn't a true science experiment. Because I am working by myself, I'm going to actually use these bowls to help me hold up the bag. You'll have somebody helping you who can help you hold your bag open. Now on my recipe, it says 1 capital T sugar. When you're doing recipes, if you see a capital T, that means tablespoon. Not teaspoon, but tablespoon. So I need 1 tablespoon of sugar. And this is my tablespoon measurer. So I'm going to take one tablespoon of sugar, and I made it fairly flat, it's not heaping. And I'm going to put that into the first bag. I'm going to take 1 teaspoon of sugar, nice and flat, and put it into the second bag. This is a recipe that doesn't necessarily matter which order you put the ingredients in. And so I'm going to skip this for a second, and I'm going to come down here. And now this says 1/4 small T vanilla extract. So remember, capital T meant tablespoon. Small t means teaspoon. So if we compare those, you'll notice that the tablespoon is way bigger than the teaspoon. And we want 1/4 teaspoon of vanilla extract. Whenever I do the liquids, I make sure I do them over the bowl. So if it spills, it's not all over the counter. So very carefully, I'm going to put in 1/4 teaspoon of vanilla into each bag. You'll notice that my vanilla is kind of a brownish tan color. Oh, that smells good. I like the smell of vanilla. Now the thing with the recipe is, if you skip around like I do, you need to make sure that you go back and pick up the stuff you forgot. Now the recipe I'm using today actually says use 1/2 cup, half and half. But remember, I decided I wanted to go with chocolate. So I'm using chocolate milk and heavy whipping cream. Now I'm supposed to put in 1/2 cup of half and half. I don't want to put in 1/2 cup of chocolate milk and 1/2 cup of whipping cream. That's going to be way too much liquid for the sugar that we put in. So what I'm going to do is, I know that if you took a half and divided it by 2, it comes out to be 1/4. So in my experiment today, I'm going to do 1/4 cup chocolate milk and 1/4 cup whipping cream. And that has to go into each bag, because remember, the two small bags have to be the same. I'm pouring a liquid, so I'm going to get my bag wide open here above the bowl, and I'm going to pour right over the bag so that if I spill a little bit, it's not too much of a problem. All right, so there is 1/4 cup chocolate milk. And 1/4 cup chocolate milk. I want to do the same thing with the heavy cream. I want to put 1/4 cup into each bag. So that's it for what's going in the bag. The next direction says to seal the bags. So I'm going to take that zipper and I'm going to seal it up. And then once it's sealed up, I'm going to take it out and kind of shake it up a bit. So we mix up the sugar and the milk and the heavy cream. And I'm going to set it back in there just for now while I do the same thing to the other one. I'm going to zip it up. Make sure that it's zipped all the way across so it doesn't leak. And shake it up, mix it up a little bit. I'm going to set those off to the side. And we're going to take 2 of the bigger bags. Now these 2 bags will not be the same. One bag is going to get the coarse salt, and the other bag is not. Remember, I'm using rock salt from the water softener, and it's 1/2 of a cup. So I'm gonna go in there, and this is okay if this goes a little bit more, but a good full scoop of salt into that one. So I know which one is which. I did mark this bag as having the salt in it. Now what we're going to do is we need to get dressed up and go outside, and we need some snow, because the snow is going to be what makes this turn into ice cream. Now we're not going to add snow into these little bags. We're going to use the cold, the temperature of the snow to make the ice cream. All right, so if you're doing this with me, you're going to need to stop right now, pause the video, and put on all your outdoor gear. If you're just following along, give me a few seconds and I'll meet you again outside. All right, so I moved all my stuff outside. I have the 2 bags of liquid that are identical to each other, and then the 1 bag with salt and the other bag without salt. Now we're going to put snow into each of these bigger bags, not into the mixture with our milk and our cream and that. Because I don't have waterproof mittens on today, I don't have snow mittens on, I did grab a small shovel. Now help me figure out how much snow I'm putting in. You want to put in about the same amount of snow into each bag. Now if you're going to do this experiment completely inside and use ice cubes, then you want to use about 4 cups of ice per bag. But with the snow, we don't have to be quite as exact. And so I'm going to take and just shovel in some big scoops of snow. That's the bag without salt. I've got it about half full right now. I'm going to take and I'm going to set the other bag with the mixture in. And then I'm going to put more snow in there. Another big scoop, and so that my bag, the little bag, is completely surrounded by snow. And then I'm going to zip it shut and give that a shake. I'm going to set that over here in the snow bank, and I'm going to do the same thing to the bag with the salt. So I put in a couple of big scoops of snow, and I'm going to kind of mix it in there with the salt on this one. Oops, lost a little bit. I'm going to take my small bag, I'm going to put it inside of there, and I'm going to add some more snow. I'm kind of tucking that little bag down into the snow like it was in the other bag. Both bags are filled about the same. I need to zip the second one shut. And you want to shake it up a little bit. We have our 2 bags roughly filled with the same amount of snow. One has salt in the snow and one does not. What do you think? Are they going to turn out the same? Or do you think maybe one will make more ice cream and one won't work? And if you think, which way is it going to go? Is the bag with the salt going to make better ice cream, or the bag without the salt? I can't wait to see the results. You're going to want to leave your bags for about 10 minutes. I'm going to put 10 minutes in on my phone, on my timer. There we go. And then we can go just play for 10 minutes. Every once in a while, though, come back and shake your bags. See what's happening. Now, one of the things I find kind of interesting is I had to take my glove off to do my phone, and I'm noticing one of the bags is colder than the other. I'm not going to tell you which one. I'm not going to tell you if it's the bag with salt or without salt that's colder. You can experiment like that on your own. But when I feel them, one of these bags is definitely colder than the other bag. So for 10 minutes, take a run around your house. Come back, shake the bag a little bit, shake the bag. Go run to a tree. If the adult that's with you says, let's go check the mail, you can do all sorts of things outside. You can make snow angels. This isn't really the right snow today for snowman making, but maybe when you do this experiment, it will be a snowman type of snow. And so you can just spend some time. But don't forget, come back and shake your bags every once in a while. See you in about 10 minutes. It's been 10 minutes, so I've grabbed my bags, and I'm going to actually head back inside, and I'll meet you in there in just a couple seconds. Before I open the bags, do you think they're going to be different from each other? Do you think they're going to be the same? If you thought they're going to be different, how are they going to be different? What do you think is going to be different? Do you think the salt made a better ice cream? Or the bag without salt made a better ice cream? Let's check the one without salt first. So when I look at that bag, it's pretty liquidy yet. Not what I would call ice cream. Let's see what happened to the bag with salt. It's actually hard. I open this up. We actually have an ice cream texture. See, not a liquid. Pretty cool. And pretty yummy. Why did this happen? Why did the bag with salt turn into ice cream while the bag without salt just get really cold, liquid-like? Let's take a little closer look at the science. And by the way, I'm going to take this bag that was in the snow without salt, and I'm going to stick it in the bag with salt. That way I'm not wasting any of my ingredients. And I'll have a treat for later. let's take a little look and see if we can get a little bit of an understanding as to why the bag with the salt froze the material and made ice cream, while the bag without the salt stayed liquid. So first of all, we want to think about snow. Snow or ice is a frozen form of water. Water can be in 3 different states. There's the frozen form, snow or ice, and when we look at the molecules of ice or water that's frozen, the little molecules, the parts that make up the water, all tend to line up. This happens for just plain water. That happens at 32 degrees Fahrenheit or 0 Celsius. So if we put it in kind of human terms, this would be a very boring party. Everybody has to stand right next to everybody else, and you don't really get a chance to go anywhere else during that party. When water is liquid, then the molecules are spread out a little bit more. So in liquid form, the molecules are still kind of in clumps, but they're spread out a little bit more and can move. You can't move much at this party. At this party, you got to stay in your cohort, but you and your cohort can move around a little bit. Do you know the 3rd state of water? We have solid, we have liquid, or water can be a gas or a vapor. The gas party is a great place to be because you can move all over the place. You can hang out with some of your friends. You can go talk to other friends. That's a fun party for the water molecules. This one, you have to hang with your cohorts. And this one, you're stuck. You got to stay where you're at. So when water is in this form, it would really like to be in that form. And so the outside layer of the ice, the outside layer of the frozen water, will melt and reform. The air around ice is usually drier, and so it can pull some of the molecules out and let them go straight into vapor. That's evaporation. But when it's cold, they stay forming in their little forms. Now when we add salt to the mix, the X's are salt. When we add salt to the mix, then that outside layer, when it melts, it mixes up with the salt. Now when water mixes with salt, the freezing temperature goes down. So 32 degrees is not where it freezes. So that bag of snow is frozen water, roughly 32 degrees. But we add salt to it, and as that starts to change, the chemicals mix together, and that temperature goes down, it's becoming more liquid. And as it becomes more liquid, it shoots off the cold. It gives off that cold vibe. So remember outside I was saying one of the bags felt colder than the other? It was the bag with salt, because as this chemical reaction was happening, the byproduct, what it was giving off, was cold. Now that cold then went into the bag with the milk and sugar mixture, and then that stuff got cold enough to actually freeze. And so that's why the bag with the salt turned into ice cream, and the other bag just stayed liquid. It wasn't cold enough. So that's a pretty simplified way of looking at it, but it'll give you a little bit of an idea as to why this experiment went this way. Now, of course, with any science experiment, you can't just take my word at it. You can't just say, oh, I saw Ruth do it, it must be true. You need to test it for yourself. So you can get those ingredients, have an adult help you, and see if you can come up with different results. Maybe you want to try amounts of salt. Maybe you're going to make more bags and see what happens if you add more salt to the mixture. Is there a point when there's too much salt and it won't form ice cream? I don't know. I've never done that experiment. Maybe I'm going to go play right now. Have some fun, and we'll see you next time.